This is Philip, your favorite mathematics teacher. You can follow my page on Facebook, Philip Ogra, and also on TikTok, Philip Ogra as well. I do videos on mathematics and interesting topics about interesting things about education. Yeah. Now today I wanted to consider the question on the board, which is WASSCE 2024 question 4. The 4 question, it was a compulsory question, and it falls under circuit theorem. Now, circuit theorem is one of the most interesting topics in mathematics, but trust me, with Sir Philip, you will find everything to be simple. Now, today I want us to consider this question. Now, when you look at the question on the board, sometimes when a circuit theorem question is given to you, you first of all have to identify the part of the circuit which has been given to you. Now, when you look at it, you can see that line PQ is a diameter. It was also even stated in the footnote, but because of the board, I couldn't write all of them. So even if the question does not state that, but you should know that since the PQ is passing through the center of the circle, it means that it's a diameter. And what also shows that a line is a diameter is that you can see that there is a 0 here and there's an indication here telling you that line PQ is passing through the center of the circle. Also, we have angle RSQ, or you can say QSR, to be 30 degrees. Then we also have STQ to be 20 degrees. Now the question said that we should calculate A, angle QRS, meaning we are looking for the angle here. Now, for when it comes to circuit theorem, one of the properties states that a diameter of a circle always subtends an angle of 90 degrees on the circumference of a circle. When we talk about the word subtend, here is the word. A diameter of a circle subtend. It means that the thing right there, me find the automobile video today like this. Now I don't know why they. Now it's here no why they. It will bounce up. Please, how we are getting it? It's why I not subtend. We should work also. So we are saying that a diameter of a circle subtend. Please, the word is subtend, not form. It subtends an angle of 90 degrees on the circumference of a circle. So you can see that when you consider diameter PQ, it subtends an angle at S. And also subtends an angle at R. Please, I hope you are getting it. Good. So it is implied that the angle PSQ, which was subtended by diameter PQ, is 90 degrees. That is, angle PQS is equal to 90 degrees. Alright. Now, so once we know that the angle angle PSQ is 90 degrees. But remember, angle PSQ comprises of PSR and also at the same time QSR. Already we know that QSR is 30 degrees. So it means that if a whole of this angle is 90 degrees and now we are saying that this side alone is 30 degrees, then automatically angle PSR becomes 90 minus 30 and that will give us 60 degrees. So the small angle here now becomes 60 degrees. Now, one of the properties about circuit theorem also state that when a chord subtends 2 or more angles on the circumference of a circle at the same segment, the angles formed are equal. So when you look at the angle 60 here, you ask yourself, which chord subtends an angle, the angle 60? When we talk about a chord, a quick one here, this is a circle. So this is our center. A chord is any line drawn from one part of the circumference to the other, but does not pass through the center of the circle. So this is a chord. I'll say AB is a chord. Are you getting it? Good. So we are saying that when a chord subtends 2 or more angles on the circumference of the circle. So when you look at this one, AB subtends angle at C. The same AB also subtends another angle at D. Now the rule is that the angles formed are equal. So this angle is equal to this one. And that's what we are applying here. So we are saying that PR, sometimes identify the chord which subtends the angle becomes a little bit dicey. So when you look at this one, 60, just assume that the 60 here is hanging. Find a kutuna or hanger so ya day. It's a kutuna or hanger so that's a push by down. You can push aqua. I have a last line. What is the last line of kutun bakotoro? Please, how you are following? Very good. So one of them 60 a day. If you can push aqua from there, the line of bakotoro PR. This shows that the angle is being subtended by the chord PR. In other words, chord PR not hold the angle 60 degrees. So let's assume the PR is a spring. It's a push way not but not or bounce up. Or you am bounce the pair, won't bounce up, but that's what bad. In other words, it shows that since PR subtends angle 60 degrees, the same PR is also coming to kill. Therefore, if here is 60, this side also becomes 60 degrees. This is how we are getting it. Good. So, it also implies that we can say angle PQR is also equal to 60 degrees. Good. Now, what we have to also consider here is that angles on the straight line always add up to what? 180 degrees. And now we are saying that angle PSQ is 90. This shows that the angle at S, that is angle QST, is also equal to 90 degrees. Yeah. Angle QST is also equal to 90 degrees because we know that angles on a straight line add up to 180 degrees. Therefore, if this side is 90, automatically this side also becomes 90 degrees. Now, we also know that the sum of the interior opposite angle of a triangle always add up to the sum of the interior opposite angle is equal to the corresponding exterior angle. This shows that 90 plus 20 is equal to RQS. Or better, somebody can also decide and say that maybe 90 plus 20 will give you 110. If you subtract 110 from 180, you get 70 degrees here. Remember, the interior angle of a triangle add up to 180. Or better still, as I said, we can say that angle RQS is equal to 90 plus 20, which is equal to 110 degrees. As I said, the sum of the interior opposite angle is equal to the corresponding exterior angle. So 90 plus 20 is equal to the exterior angle here. And this shows that angle RQS is equal to 110 degrees. Now we are looking for angle QRS. We are looking for the angle here. So probably you can decide that maybe, okay, let's make this side as X. Good. So since that we know that angle RQS is 110 degrees, we also know angle RQS, angle QSR to be 30 degrees. Then we can conclude by saying that alright, so we can say that 30 plus the 110 we had plus the X is equal to 180 degrees. Remember, the sum of the interior angle of a triangle add up to 180. So we can say that X is equal to 180 minus 140. Remember, 110 plus 30 will give us 140. So X is equal to 40 degrees. So we can say that therefore angle QRS is equal to 40 degrees. So now we know the angle here to be 40 degrees. Okay, now we also say they also have to look for angle PQS. Angle PQS, meaning we are looking for the angle here. Remember, we already know that RQS is 110 degrees. So if RQS is equal to 110 degrees, and we know that, so we know that this side is 60, it automatically means that say it is 110, when we subtract the 60 from 110, and that will give us 50 degrees here. So that's how you are getting it. Very good. So the B aspect of the question, which tells you look for angle PQS, it simply implies 110 minus 60 degrees. And that will give us 50 degrees. Alright, so you see how interesting it is. I'm believing that maybe some of you already have the basis in circuit theorem. If not, you can kindly follow my page, or you can contact me on 0245 126 419, and I can take you through the circuit theorem info. And trust me, with Sir Philip, mathematics becomes very simple. Remember, mathematics is life. Therefore, always develop interest for mathematics, and I'm believing that the Most High God will continue to bless your effort with success. Thank you for watching this video. Once again, my number is 0245 126 419, or you can follow my page on Facebook, Philip Ogra, and also on TikTok, Philip Ogra as well. Thank you, and God bless you for sharing this video to the people out there.